In this video, you and I have the opportunity to design a small network where we can play with DHCP snooping. We'll then apply the commands and then verify that it's working. So here's what I propose we do as our plan, and it's simply this. We'll have a switch, an access layer switch, and let's plug in a couple of DHCP servers. So there's going to be DHCP server 1 and 2, and we'll make this the good guy, and we'll make this one the bad guy. Maybe I should use red for that. All right. Rah, mad and evil. Okay. And then we'll put a couple clients over here. So we have PC1 and PC2. And if we just bring up a new switch, all the ports will be in VLAN 1 by default. So they're all going to be in the same VLAN. And then for our plan, for this DHCP server, let's go ahead and use the IP addressing space of 10.16.20.0 with a 24-bit mask. And for this DHCP server, let's have it hand out IP addresses from the 1099.99 network, so it's very obvious which clients get what. And we'll make PC1 and PC2 both DHCP clients. So here's some fun news. We have many options as we create in a lab environment DHCP servers. We could take Cisco routers, we can enable DHCP by making the pools, assigning the networks and the default gateways and everything else, or we could use a simulator. In fact, I did a series of videos on Packet Tracer. And Packet Tracer is an amazing tool at both the CCNA level and for much of the CCNP for regarding routing and switching. So here's what I propose we do. Let's take the design we just talked about and let's build that live inside of Packet Tracer, and then we can follow it up by implementing DHCP snooping on top of that to verify it works. And if you haven't yet taken a look at the Packet Tracer videos right here at CPT Nuggets, please take a moment to look at those. This is a fantastic and easy tool to use. So let's together start with a blank canvas and let's build a simple network. Let's start with the switch. So down here on the bottom left, we'll click on Network Devices, click on Switch, and let's just go ahead and grab the 2960 switch and drag and drop it. Boom, done. Next, let's grab a couple of DHCP servers. So we'll click on the End Devices icon here, and then over here we'll grab the server icon, grab a server, and then we'll grab another server. We can change the labels on those if you want to. And then let's grab some PCs. So we'll grab a PC, drag it up, and let's grab a laptop and drag it up, and let's connect them all together. So to connect them all together, we can grab the connection tool, and then we can use the automatic connection tool and just click and click. Automatic connection tool, click, click. Automatic connection tool, click, click. Automatic connection tool, click, click. And in the Packet Tracer videos, I walk you through how you can change the options to show the labels or not show the labels and the LED indicators and so forth. Lots of fun to be had. So I'm going to stretch these out just a little bit. And let me rename a few of these things. So I'm going to call this top server, I'm going to call it DHCP good. And we'll call the bottom one DHCP bad. There we go. That way we can identify both of them. And we'll call this top device PC1. And we'll call this device PC2. Fantastic. So for the switch, let's just verify that all the ports are associated with VLAN 1 by default. So we'll click on the switch and we'll go to the CLI tab, press enter a few times, go into privilege mode, do a show VLAN brief. And I'm going to expand this a little bit so it's a little easier to read. There we go. And sure enough, all the ports by default are in VLAN 1, so we're good to go from that perspective. Next, since we're here at the switch, let's go ahead and enable IP DHCP snooping with the command IP DHCP snooping, just like that. So we'll do a do show IP DHCP snooping, press enter, and this says that DHCP snooping is enabled, but it's currently not applied to any VLANs. So we'll take care of that in a moment. It's also saying that the insertion of option 82 is enabled, which we want to disable because we're not using a relay agent for DHCP. So the next command we'll do is IP DHCP snooping VLAN space, and then we'll apply this to VLAN 1 because that's where all of our ports are. Boom. Now if we do a show IP DHCP snooping and press enter, now it's showing that DHCP snooping is enabled and it's also configured for VLAN 1. So next let's take care of this bad boy. Insertion of option 82 is enabled. So we'll do a no IP DHCP snooping and say information option, press enter. Then a couple up arrow keys to do a show IP DHCP snooping, press enter, and now the insertion of option 82 is disabled. So if we do a do show history, press enter, here are the commands that we've issued. IP DHCP snooping, IP DHCP snooping for VLAN 1, and no IP DHCP snooping information option. Now, we have one other little problem that's going to arise. When we tell these clients to be DHCP clients and they do their discover messages, and then those discover messages are sent to all other ports in the same VLAN because they're broadcast, DHCP good and DHCP bad, once configured, are both going to do offers. So we'll get an offer from DHCP good, an offer from DHCP bad, and because all of these 4 ports are all untrusted by default once we enable DHCP snooping, the switch ports, FA0/1 and FA0/2, are going to drop those offers. And these clients are not going to get their responses. So we also need to tell the switch that this port, FA0/1, which leads to the real DHCP server that we want to use, that this port is a trusted port. So let's do that also. So we'll go back to the switch. And here at the switch, we'll go into interface. Let me take a peek at what that interface is. It is fast Ethernet 0/1. So we'll go to interface FA0/1, and we'll say IP DHCP snooping space and trust. Enter. Boom. That's now a trusted port, and we can verify that with a show IP DHCP snooping. Press enter, and there it shows that FA0/1 is trusted. It also shows that DHCP snooping is enabled, and it's also enabled for VLAN 1. Fantastic. All right, now to actually test this and make it work, we've got to do a little bit of work on the 2 DHCP servers to make sure they're up and active, and then we also need to turn on some clients and make sure they're DHCP clients. So let's start with DHCP good here in Packet Tracer. We'll go ahead and click on it to open up the window for that. And here on the window for DHCP good, we'll click on config. We'll click on fast Ethernet 0. We'll specify it has a static address of 10.16. Let's see here. Let's use 20 for that subnet. Let me look at our plan. So our plan was 10.16.20 will be the network it's handing out. So we'll put in 10.16.20. And let's use the first IP address in that range with a mask of 255.255.255.0. Fantastic. So now it has an IP address. Next, let's make sure it's enabled for DHCP services. So here for this machine, we'll go to services. We'll go to DHCP here on the left. And with DHCP selected, we'll specify that we want DHCP services on. And we can specify the range. So let's go ahead and start the range at 101 for the first valid IP address in the 10.16.20 network. Fantastic. All right, so it is done. Let's go ahead and close that. Let's also configure DHCP bad. And on DHCP bad, we'll bring that window in the viewing space here. And on DHCP bad, we'll go to config. We'll go to its interface, and let's go ahead and use 10.99.99.1. We'll take the first IP address with a 24-bit mask. That's great. And let's go to services and DHCP and say that we want to enable it. And let's start at 101. So 10.99.9.101 will be the starting address for the pool of addresses that the DHCP bad server is going to try to hand out. So now, with DHCP good set up with an IP address and DHCP services enabled, and DHCP bad also set up with a different IP address and different range of addresses, let's go ahead and enable the 2 clients to be DHCP clients and see which IP addresses they pull from, the good DHCP server or the bad. Now, our intention is that because DHCP snooping is enabled and it's also set up for VLAN 1, and the port that's connected to the bad DHCP server is not trusted, anytime that server tries to do offers, those should be rejected and not make it into the network. Let's test it. So here on the PC, we'll just click on it to bring up the console for that. And we'll go to config. We'll go to fast Ethernet 0. And we'll simply click on this radio button and watch this field right here. 10.16.20. Oh, .2. Didn't I tell it to start at 100? Let's go check the DHCP server. So it got the IP address from the correct DHCP server, but I think the range isn't quite what I expected. So let's go back to the DHCP server, go back to services, DHCP. Oh, okay. So for some reason, the starting address, I thought I put in a higher number like 101 or something, and it didn't take. That's okay. I can live with that. And let's go to PC2 and make it a DHCP client as well. So we'll go to config, fast Ethernet 0, DHCP, and survey says 3. All right, so I must have mucked up the starting range. Here's the server again. I mean, I am curious. So DHCP, yeah, it's not keeping that. So start address, it just didn't want to keep the start address. Fair enough. All right, so it's not starting off at 101 or 100. It's starting off with the first next available address, which is okay. The goal here is to verify that we're getting the IP addresses from the correct server and not from the DHCP bad server. So let's go back to the switch and let's verify what's going on. So if we do an up arrow key, show IP DHCP snooping, press enter, it's showing us here that fast Ethernet 0/1 is a trusted port, that 02, 03, 04 are all untrusted, and as a result, that's why the bad DHCP server didn't have the opportunity to respond and get any of its offers into the switch. And if we also did one other command, show IP DHCP snooping binding, this is going to give us information about the layer 2 addresses and the corresponding IP addresses that have been learned via DHCP snooping. So this says that the client at 10.16.20.2 has this MAC address, and the client with this IP address has this corresponding MAC address. In this video, we did 3 basic things. Number 1, we designed a network. 2, we put that network in place inside a packet tracer. And 3rd, we implemented and verified DHCP snooping to protect the network against rogue DHCP servers that otherwise may be accidentally or intentionally added to our network. And this can protect us against those types of attacks. And here's the reason why this is important, is because in production networks, rogue DHCP servers do get introduced all the time. And a lot of times it's accidental. People bringing in stuff from home, they didn't realize DHCP services were enabled on it, and there's a disruption of network services. So it's important to understand the concept, to practice it, to see the results, verify it, and that way, when it comes time for us to either implement this or verify this or troubleshoot this in a production environment, we'll be that much more ready to help defend and protect our networks. So I'm glad you joined me in this video. I hope this has been informative for you, and I'd like to thank you for viewing.